Hey everyone, and welcome. Today we're going to unbox artificial intelligence, right? We hear this term everywhere, but what's actually inside the box? Let's get past all the hype and the buzzwords and see how these machines really learn.
So, to get started, let's just ask a really simple question. And you can forget about computers for a second. If you wanted to learn how to bake the perfect cake, how would you go about it? Just think about that for a moment, because your answer, it probably falls into one of two camps.
So, on one hand, you could just follow a recipe, right? A super precise step-by-step list of instructions, a clear set of explicit rules. Or you could watch an expert baker. Maybe it's a friend, your grandma, someone on YouTube, and you just try to copy what they do. You learn by watching their examples. And it turns out these two really human ways of learning, they are the absolute key to understanding everything about AI.
Because believe it or not, those two approaches, learning by following rules and learning from examples, are the exact two paths that the entire field of artificial intelligence has walked down. For a long time, I'm talking from the 1950s all the way through the 80s, AI was all about that first approach, following a recipe. This was called symbolic AI. And the whole idea was, if you could just write enough detailed rules, enough instructions, you could make a machine do pretty much anything intelligently. I mean, think of it like trying to write the world's biggest, most comprehensive cookbook for a computer.
But this leads to a huge problem. What happens when the task is just too complicated for a recipe? What do you do when you can't possibly write down all the rules?
Let's look at a quick example. So take this task, converting a color photo to black and white. For a rules-based system, this is super easy. You can write a pretty simple math formula that just takes the color value of every single pixel and averages it out. The rules are clear, the result is always the same, no problem.
Okay, now let's crank up the difficulty. What if you ask the machine to not just crop a photo, but to figure out how to crop it? To make a good composition. Well, this is way more subtle. How do you write a rule that tells a computer what's important in a picture? You'd need rules for faces, for objects, for leading lines, and suddenly things get really complicated fast.
And this is where the whole rules-based approach just completely hits a wall. What about making an object just disappear from a photo and then intelligently filling in the background behind it? I mean, it's pretty much impossible. You just can't write instructions for every possible object in every single background that could ever exist. The cookbook approach just fails.
So if writing a giant book of rules doesn't work for complex problems, what's the alternative? Well, it takes us right back to that second way of learning we talked about, learning from experience. And in the world of AI, we call this machine learning.
And what's wild is, this idea isn't even new. In fact, way back in the 1950s, while symbolic AI was getting all the attention, this one researcher at IBM, Arthur Samuel, he had a totally different idea. He thought, instead of trying to teach a computer all the rules of how to be a great checkers player, what if you just program the basic rules of the game and then just let the computer play against itself thousands and thousands of times? It literally taught itself what moves led to winning, not from a human telling it, but purely from its own experience. And that one simple idea? Well, that's what powers almost all the AI you interact with today.
And if you want a really solid definition, Tom Mitchell, who's a huge pioneer in this field, put it perfectly. He said machine learning is the study of algorithms that let computer programs automatically improve through experience. And that word automatically, that's the whole ballgame. The machine gets better all on its own, without a person needing to write new rules for it every single time.
So how does this automatic improvement thing actually work? Well, imagine you're teaching a computer to recognize a panda. First, you show it a picture, and it guesses, let's say, not a panda. Then you give it feedback. You tell it the correct answer. Nope, that's a panda. The machine makes a note of its mistake and makes a tiny adjustment to its internal wiring. And then you just do it again and again and again. Thousands, even millions of times, with pictures of pandas and pictures of everything that isn't a panda. It learns, little by little, from every single one of its successes and every single one of its failures.
Okay, so we get the what. It's learning from experience. But how? How does a machine actually adjust its internal logic? Let's crack open that black box for a second and look inside a machine learning model, and we'll use a really simple, everyday analogy to do it.
All right, just picture a smart toaster oven. The slice of bread you put inside, that's your input. The details about that bread, its size, what type it is, how thick it is, we call those its features. The toaster oven itself, that's the model. And its settings, the heat and time knobs, those are its parameters. And what comes out at the end? The toast, of course. That's the output.
And that little picture on the box of the perfectly golden brown piece of toast you're hoping for, that's your goal. We call that the label.
Now, here's where the magic, the learning, actually happens. There's a process called an optimizer that looks at the toast that came out and compares it to that picture of the perfect toast. And based on that feedback, is it too burnt? Is it not done enough? It automatically goes back and makes these tiny adjustments to the heat and time knobs, to the parameters. The goal is that the next slice of bread comes out just a little bit closer to perfect. And this brings up a really important difference in how AI works. This whole process of the toaster adjusting its own knobs, that's called the training phase. You can think of it like the model is in a test kitchen, burning a whole lot of bread just to figure things out. But once it's fully trained and you're actually using it, that's called the inference phase. Now it's in your kitchen at home. Its parameters, those knobs, they're now locked in place, and it just makes great toast based on everything it learned before. Your apps on your phone, they aren't relearning from scratch every time you open them. They're in that inference phase. Okay, so let's take a step back and put all these pieces together. We've got the old way, symbolic AI, which uses rules, and we have machine learning, which learns from examples using models and parameters and feedback. But there's actually one more really important layer to all this.
And that final layer is deep learning. You can basically think of it as machine learning on steroids. So if our simple toaster model had two knobs to turn, a deep learning model, which is called a neural network, is like a giant control panel with millions of tiny interconnected knobs. All of these parameters let it learn incredibly complex and subtle patterns from data, things that are way beyond what a simpler model could ever hope to grasp.
So here's the absolute key takeaway. This is how all these buzzwords fit together. Artificial intelligence is the big, overarching goal, making machines smart. Machine learning is a specific approach to get there, letting the machines learn from data instead of just programming rules. And deep learning models, or neural networks, those are the most powerful tools we have right now to actually get the job done.
And this takes us right back to the real world. You know that magic portrait mode feature that blurs the background in your photos? Well, that's a deep learning model that learned from millions of images what a person looks like versus what a background looks like. That chatbot that can answer almost any question? It's a deep learning model that learned by reading a huge chunk of the internet how human language and conversation actually work. It's all just learning from experience, but on a mind-boggling scale.
So we started with the two ways that we humans learn, by following rules and by learning from experience. We've seen how AI has followed that very same path and has found this incredible power in learning from experience. And it kind of leaves us with this one final fascinating question. If machines can now learn from experience on a scale that is far greater than any single human could ever hope to, what will they eventually teach us?